Hey guys, yesterday I posted a video where I was sharing this asset that I've made, but I also wanted to share my thought process on how I did this node. It's not very complex, you will see, but I was kind of happy with how I figured this out, and I just wanted to share with you guys how I did it. So yeah, let's just do it. You can see the piano reacts to the music, to the MIDI file. Yeah, it's pretty cool. So the first thing you need is a MIDI file, obviously. In Blender, for example, you have a couple import nodes, and the one that piqued my interest is a CSV, because CSV is a point cloud and has a bunch of attributes on it. It's useful for like data visualization and all of that stuff. I have like a friend of mine who uses a lot CSV in his work about statistics and stuff. That's like what CSV is for, but you can actually use it for like animation stuff. I just went on Google and typed MIDI to CSV, and I found this website here. It's called MIDI to CSV.versal.app, and you can just upload the MIDI file, select it, open, and then you can see that it looks like attributes, and that's exactly what we want. It has the MIDI note, the velocity, the duration, and the time, and all we need really for the animation. So you can see that I can just click on CSV and type download, and now we have a CSV file. In my personal case, for sharing the tool online, I didn't want to ask people to convert on a website that I don't have control on. So my brother, who actually can program stuff in Python and C++ and stuff, he helped me to come with a Python script that converts MIDI files to CSV. I asked ChatGPT as well. It's like VAP coding, and I have some help from my brother. I can just like take the MIDI path right here. If I were to delete the CSV right here and I click convert MIDI to CSV, I have the CSV right here, which is converted directly from Blender to my folder. So now that I have a CSV, I can just import it right here, and I can preview this as well. So I can get rid of the group input node. Let's see the attributes. So I can open the spreadsheet right here, and the point cloud. I just want to see the point cloud here. You can see that it shows me all the attributes that we want. So the MIDI note, the velocity, duration, and time. And from this, you can already recreate the MIDI notes that you see on YouTube videos. Like you see this kind of videos where like the notes fall down on a piano. Like you can recreate this quite easily. And I just want to show you how I use the attributes just to visually recreate the MIDI lines, you know. Let me just put this in full view. And actually I will increase the size of the viewport just so you can see better. Nice. Okay. So right now we don't see anything. If I zoom in a lot, you will see the points right here. And these points have like the index value and the MIDI note as well. So for now, I will just do a set position, and then we'll move just on the X axis. So I just want all my notes to be reparted on the X axis right here. So I will just use the name attribute. For this one, we'll use the MIDI note. Okay. And if I plug this on the X axis, if I dezoom a lot, I have a few points right here. And I want now to represent the time on the Y axis. So I will just do a named attribute, and we have the time right here, time in seconds, and I can put it in the Y axis. Okay, so now you can see it already looks pretty interesting, but it's just points. We want the duration as well. So what we can do is change the points to vertices just so we can extrude them later. So points to vertices, and now we can extrude. We will extrude on vertices, and in the offset we still want the Y axis to be the time, so we'll just do 1 on the Y axis. And for the scale, we're going to use the duration attribute. Perfect. So now we can't really see well. I can maybe increase the opacity of the wireframe. But for real visualization, we're going to convert the mesh to curve. So mesh to curve. And then since we're in 5.1, we have the curve to tube node, which is a custom node group that comes with Blender when you install it. So you can see the inside is pretty terrifying. I wouldn't want to decode this. But yeah, this is just so we can convert everything to tube. And now look, it's already pretty interesting. I was thinking maybe instead of tubes, we can do a curve to mesh, and then just use a curve line here. And then in the direction, we're gonna do maybe X, like 0.1 and minus 0.1. Okay, so now it's just like rectangles. And yeah, so that's actually the MIDI track. And if we want, we can retime everything. So we can just do a math multiply the time and the duration by the same value. So value. And now this scales it up just so we can see better what's happening. Okay, I'm just giving a solo extrusion just so it looks nice. And if you still don't trust me that this is actually the track, we can play it. So right in between these, we can do a set position. So it's starting to be a bit bulky, so we can just move everything. And I'm gonna offset in the y-axis. So we said the y is the time, so we're just gonna do a sin time. And since the duration and the time is in seconds, we're gonna use the seconds to move. And if I press play, you can see that it's moving. But since we scaled everything with this value, we also want to scale the time seconds with the same factor right here. And now it works. It looks like the time is playing backwards, so we also want to multiply it by -1. And now like this red line represents the present time. Let me just change my frame rate to 60 FPS because it feels a bit smoother. And now you can see that every time the note hits the red line, it should technically be when the note is playing. And to make sure this actually works, we can layer the music on top. Let's go in video editing, scene, and I will add a sound. And I have the sound on my PC, so I can just place it here. Okay, and let's just see. Okay, so I just changed the CSV just because it has a lot more notes and it's easier to see. Yeah, it looks like it's working. You can see, for example, these two notes when I play the music. It's actually working, so that's interesting. And now basically what we want to see, to animate a full piano with it, every time a note is touching the red line, then we should play the corresponding notes on the piano. The first thing I want to do is to set up a piano. I will just model it real quick. Okay, so I just made it very quick, but it's just to showcase, so it's fine. The first thing we want to do is to convert all these notes in instances. So it's not really complex. There is this node that's called split to instances, and it works, but first you have to set the mesh island here. So now each node is a separate instance, but the issue is they all have the center points, this one here, the origin point. So if I were to rotate everything, so rotate instances, you can see that if it's on the x-axis, it works, but if it's on the y, I like them to all rotate on their own space. So what we have to do is to, before it's set to instances, we want to place them all in the center. So we can just do a set position and use position. We want to see the average position for each mesh island. So we can use a field average node set to vector. You just plug it here. And we want to use the mesh island for the group ID. This is going to return like the mean, like the average position for each mesh island. If I plug this into the offset, it's gonna look weird, but we just have to inverse this. So we have to scale by -1. It's all gonna place it in the center. But then we have to place them back after we set to instances. So if we do a set position and we try to plug any of this, like the mean in the offset, it's not gonna work. It's just because this is calculating, like the field average is calculating on the mesh island, and an instance doesn't have a mesh island. It's a bit unintuitive, but we have to first split everything to instances, and then for each instance do this exact operation, but using an attribute statistic node. This is great because it just returns a single value which can be used anywhere in the node tree. So we can just do split to instance and do it first here, and then we want to do a for each element. Plug this in here, and this in here, and this in here as well. And we want to do for each instance. Then we want to realize the instance. And now instead of using a field average, we want to use an attribute statistic. We're gonna connect this geometry here, set it to vector, plug in the position. We can remove the mesh island because we don't need it anymore. And we can plug the mean right here, and then the mean in the offset right here. And now all of the instances are placed back into the proper position, which means that now if I were to rotate instances, the x-axis works just like before, but then the y and the z, everything is centered. And you can see that if I do on the x, now it doesn't rotate in the proper place. So we can just right here, after finding the mean position, we can just offset it. So we can just do a vector math set to add, and we can play with the values. And so now it rotates just like before. So that's great. Great. So now we have our instances. And if we look in the spreadsheet, we can see that we have the instances right here, and all of these have a index value, and each index value corresponds to the node on the MIDI file. So if we were to import CSV and import this CSV file, and I look at the point cloud, this index value corresponds to the note that's being played in the time order. Like this is the first note that's being played, then the second one, etc. But what we're interested about is the MIDI note right here. If it says 50 on the MIDI note, it should move the index 50. And there's no like obvious way in geometry notes to say move instance 50 down at this moment in time. So like you could do this, you could do sample index 0. And then what we want to sample is sample the named attribute, and it's gonna be MIDI note right here. And then we can compare the value to the index value of the instance. So if I do a set position and I say move it down, okay, so now all the notes are moving down. But what we want to do is to move down only the notes that we want. So let's do a switch just in the Z axis right here. And we want the up position, which is 0, and the down position, which is a bit below. But then the switch, we want to do a compare set to integer. Then just plug this value here and compare it to the index of the current node. And if we plug this here, and we just want to compare if it's equal, and then you can see that it's moving the node 50. You can see that if I do the exact same thing and I type in 50, and I plug this in here, that's like the same result. But there's a weird thing that's happening is, look what happens if I like change the value. Okay, so it looks like it's random. And we want to reorganize every index for each node to go from 0 to however many amount of node there is, depending on the x-axis, for example. So we can just do the sort elements set to instance. And in the sort weight, we want to use the x-axis of the position. And now, if we plug the switch, so let me just organize everything quickly. If we plug the switch here, now it's actually moving. If you are to count like from this node to this one, there is 50 nodes. So if I do the same thing as before, set it to 50 and plug in here, when I change the value, it's actually going down, and it looks like it should happen this way. So that's already a first step. But now, how do we tell which node should go down depending on the time? And we have all the data that we need actually. So let's keep this for now. Actually, let's get rid of it. We want to select only the notes that are being played. So we can actually do this by sampling the index and do it for the time attribute, time in seconds, and do it for the duration. And let's just evaluate it on the index. So now we have the time here and the duration here. And to find the exact selection on the present time, like when it's being played, all we have to do is look at the time, like the scene time, and compare it. Is the scene greater than time? So if it's greater than time, like when it's played, then it's probably playing. But we also want to see, is it less than the duration? But we don't want to see the duration, because the duration is only like a couple of seconds or something like that. We want to see time plus duration. So let's do math, time and duration. So this is like, this returns like when the node ends basically. And now we want to see the range. If it's greater than time and lower than the time plus duration, then it should be in the present time. It should be playing now. And the way we do this is Boolean math, and we do n. So it's greater than and less than. Then if it's greater than this and less than this, then the Boolean can return true. So this is our selection. So if I were to take the CSV, which is right here, just take it back here, and we separate the geometry. So I can separate this and this. Now if I look at the selection, so right now there's no nodes playing, but if I press play and I have my mouse over this, you can see that all the notes that appear, they're like the MIDI notes that are currently playing, which is really interesting. But now how do we say, so like we have like two notes, 74 and 52 in this case. How do we actually move these notes on the keyboard? And I know it does sound like a simple task. This is actually harder than it looks, because it appears so easy. You know, you have the data right here, 76 and 65. So you could be tempted to just do a sample index node and just say, okay, so what's the MIDI note for this one? Just preview this, MIDI note. Okay, just plug this into the value. And this returns the MIDI notes for like the index 0. So let's just take this and see what happens. Since we're only sampling the index 0, we can actually compare it to the index of the instances. So instance, we know that we want to move, in our case, the note 76. So we just have to compare it. We want to compare it to the index of the instances. So if we plug this into the switch, and this is very important to understand this how it works in geometry nodes. If I take the index node and I plug this in here, and then I plug this in here, the index node that's right here is evaluating the index of the instances and not the points. So that's very important. I'm not sampling index 0 or anything. I'm sampling the index value of the instance. So in our case, I'm just saying, okay, is the value here equal to any of these index in the instances? And in this case, yes, it is equal to 76. And that's why if I look at what's moving, okay, so I just have to set this to equal. Now the not 76, which is this one, is actually down. But how do you find the proper keys at the same time? When I first did this, I was trying to do index here as well, and it was not working. And the reason is now if I press play, only like the first few notes are going to play. And it's because I was thinking, okay, I'm just sampling the index from the point cloud, which was completely wrong. The solution I found is do this operation as many times as there is notes that are playing at the same time. So all we have to do is a repeat zone, repeat, plug this in here. And what we want to do here is the iteration. If we plug the iteration, it's going to say for the first iteration, sample the point 0 and see if it's equal or not to the index. And for now, the index is nothing because we connected it to nothing. But when we will output the results here into the switch, we will see it will be evaluated on the instance index. So now, even if I repeat this, it's not adding anything on top. So what we want to do is to do a Boolean math and do a OR, which is the equivalent of adds in regular math. You plug this in here. So now every iteration is gonna add the selection on top of the previous one, which is great. I guess, for example, at frame 76, we have the note 45 and 76 that's playing. That's a coincidence, but let's do, frame 74. For example, we have 77, 45, and 76. 3 notes in total. And if we look at the set position, there's 1 note that's playing, and we know there's 3 notes playing in total. So we put the iteration count to 3. So we have this one, and this one. But how do we know the count we should put? We just use the domain size. Because we separated the geometry, we can just count the amount of points that we have, and we can just put it here. So now it says repeat it as many points as there is in the selection. So now we don't even have to think about it. We can just press play, and now the proper notes are actually playing. We're actually moving the proper notes at the proper time. So that's great. That's working. And congratulations, because you see that the setup is pretty easy actually. And that's nice. Yeah, I'm happy about it. And now it looks cool, but it's harsh. It's a harsh transition. How do we actually make a nice looking animation? And that's another question. So remember when you first did the selection, it was using booleans. It's like a harsh cut, you know, it's 0, 1, 0, 1. There's no like 0, 5 or anything like that. The question we can ask ourselves is what would be a way to find the selection, but extend it a bit on the sides. So it's not precisely at the time that it's playing. We kind of extend a bit the selection and have like an interpolation in between. So let's do some shader work. I just want to show you some stuff. Okay, so I have this plane here. And I just want to see the position. Okay, the position, separate X, Y, Z. Okay, this is just a gradient for preview. If I do a compare node, I can compare this. So this is set to equal, but let's do greater than. You can see that this is like our selection, just like we did with the timing, but this is more visually appealing, you know? What we want is to not like do some sort of gradient in between, but in our case, when the MIDI says that this is like when it's playing, we don't want the gradients to be like 0 and 1 here. We want it to start, we want it to be 1 here and maybe 0 here. So that's very important. So how do we do a gradient? And this is actually very easy. If you use a map range, you plug this in here, you can see that I have the from mean and from max. This is from between 0 and 1, so we don't change this. We want to change the range. And if I set the from max to what we set in the greater than, so you just copy this value and plug it in here, and just make sure that the from mean is below the from max, just so it makes sure it makes sense. Now we actually have exactly what we want. So if we do the greater than, if we draw like where we did the greater than selection, and if we look at the map range, now we can see that the very end of the gradients is here, and then we have like the extension here. So that's great. And we can do the same thing with the less than. So if we do this and do less than, and let's do less than here, for example, I can do a map range, and all we have to do is exactly the same thing. So just take this, set this to from max here, and the from mean should be slightly above this time. And now if we decide to do a math multiply, this is like the range that we have. Okay, so let's do a math add and math subtract, and let's have the value. This one is greater than, and this one is less than. Actually, it's quite the opposite. This one should be set to subtract. So now you can plug the greater than into the maximum, and the less than right here into the maximum as well. But for the minimum here, that should be here, just plug the value here and you subtract some value here. And you do the same here, add, and now we have another value. We'll call it gradients or something like that, and just plug it in here. Let's do 0.1 for now. So now this value represents the greater than, and this value represents the less than, and we can actually see them separately. And you can see if I set the gradient to 0.01 or something like very close to 0 but not 0 exactly, it looks like exactly what we had before, but now we can increase this and it will have some nice gradient. So the reason I mentioned we're in 5.1 is just because now we can actually copy paste nodes from one instance of Blender to another. So I just want to convert all this to node groups. Okay, so I will just take this and this, set it to a node group. Okay, so now this is our custom compare nodes, smooth, greater than. Okay, let's call this one greater than, and this one smooth. And let's actually remove the from max and just add the greater than right here. I like to have colors and stuff, so I just make this to convector, and I'll duplicate the node, click on the 2, rename this one less than, go back in and change the subtract to add. So now these are our new node groups that we can copy paste. Okay, just copy, go back to our piano animation scene and paste them here. Okay, so it actually doesn't work because you can copy paste node groups, but let's just ungroup them, Control Alt G. Okay, and let's copy this and paste this here. Okay, let's make it a group again. Okay, so we said this here. This is greater than, and this is a smooth. Just paste here. Okay, so let's rename everything greater than smooth. Let's actually call this one threshold, just like it's exactly like the compare node. Let's call this smooth greater than. Make sure this is connected to the output. Now do the same thing. Click on the 2, rename it smooth less than, and change this from subtract to add. So now we have the amazing part, which means we only have to plug everything we need. Compare from the seconds right here, and compare the first one to the time and the second one to the time plus duration right here. And what do we do with this? These are not exactly selections, so what we can do is just do a math multiply, just like we did in the shaders. And then this result we can actually compare. If it's greater than 0, we can set it to selection instead. So now we can actually get rid of those. So now the nodes will be selected with a slight time extension, and this allows just so we can add the animation. And before we separate everything, we can actually sample the thing here, and we'll call it, I don't know, gradient selection. And if I look at the separation, we have a new attribute which is called gradient selection, and now it basically says if it's 1 it's fully played, and if it's in between, the nodes should be slightly in the animation process. Okay, so the issue is before what we did was move directly the points. There's nothing in between. We take the selection, we move it down. Now what I will do is first separate it. So separate geometry. Okay, let's separate the geometry and the instance. It's very important because we're working with instance, and the selection will be the selection that we found. So now we're just selecting the nodes that are moving down, and we have the instances, and since we only have 5 instances down, the amount of instances that we have should be exactly the same that the amount of points that we have. So that's the first idea. Now if we look at the instances, the index count should be in the same order than the sort element that we have. For example, index 0 should be the nodes that the lowest. In the case of our point clouds, the index 0 is, in our case, this is the lowest, but it can be the highest as well. It can be, like you can see that it goes from 49 to 52 to 79, but then back to 57, which is a bit lower. So what we can do is actually sort elements set on points, and for the sort weight we're going to use the MIDI node. Okay, so now you can see the difference. If you look right here, it's actually in the same order than the instances. So the lowest node is indeed the index 0, and the highest node is indeed the last index. And that's exactly what we need, because now we can just sample index. We'll sample on the index, because we will transfer the attribute, which is gradient selection, set to float right here. Now the index is the same. We have exactly the same index in the same order than we want. And now instead of using a switch, we'll use a mix between, so exactly the same as before, but between 0 and minus 0.25. But now we have a float factor, which is exactly what we need compared to the switch. So just plug this in here. And now put the selection in here and plug the result of the sample index into the factor. Now you can see that the notes are actually playing. They're like moving down and moving back up, which is exactly what we wanted. And all we have to do now is to join geometry and join the non-moving pieces back. And look, that's working. So that's really great. But it looks a bit weird. Yeah, honestly, I don't really like it. But it's nice. It's fine because we have all the control in the world right here. We can actually pick how we want the animation to look like when it goes down and when it goes back up. So this is when it goes down and this is when it goes back up. And since it's a linear gradient between 0 and 1, we can just put a float curve right here. And this is like the graph editor in animation. I can just put one on the top and one on the bottom. This is like the timing. So how fast is it going down? So this is a tenth of a second. I mean, for me, the timing is not too bad. Maybe it could be a bit faster. So maybe 0.05. This is twice faster. And I want the not to go like, like. So I think I want it to be this way. Yeah, I think it's working. Yeah, that's nice. And then when it goes back up, I want it to have like the same type of motion. And maybe I want it to bounce a bit. And let's see how it looks. So it looks like it's bouncing a bit. Maybe I can do a slightly longer animation. So it is bouncing, but it's a bit weird. I'm not like an actual animator or anything. So you can see how it's almost going back up, but it's not really going back up. So maybe we can just do the animation to just be like this and do 0.1 or something like that. All right. So now it's up to your likings. And yeah, I think that what we've done today is slightly better than the thing I shared yesterday. So I might actually update it. The cool part is you can see here I did set position, and some people complain that it's just moving down and it's not actually rotating. You can actually do a set instance transform. So actually, let's do this for now. Set instance transform, then combine transform, and then instance transform. Separate. Okay, I know it's a bit long. Separate transform. Okay, let's just plug the translation here, and now we can actually change the X rotation here. Okay, nice. X rotation. So what we want to do is to combine XYZ and do a mix float between those. Just find the proper like going down thing. Okay, it's going way too down. Okay, that's way too much. Okay, let's put this to 1 and just make sure that we like it. Okay, just like this. Okay, nice. Press play. All right, now it's actually rotating. And if you don't like the fact that it's rotating right at the roots, because the piano should be rotating maybe more from here, we can always change the offset right here. So I think it should be on the y-axis, which is here. So just move it maybe like twice as much. All right, and then just make sure that the rotation is fitting properly. Okay, and look at how it looks now. Nice. So now it's actually rotating and not just going back, just not going down. So that's great. I think I will update the file on Gumroad, and you can actually get it. I will put a link in the description. If you want to skip everything that I've did today, just get the file, just play with the animation thing. I will share the link, and hopefully you guys learned something in this video. It took me, like, the setup in its, if you look at it, it's really simple. It's not a lot of nodes, but I had to use my brain to find this. So I hope you guys like it, and have a great one.